Good afternoon, my YouTube viewers. In this particular video, what we're going to be talking about is some more experimental design. And the experimental design that we're going to be talking about is split plot design. And it's when one factor is more challenging to randomize than another. Split plot designs allow researchers to study both factors effectively. For example, different fertilizers can be applied to fields, main plots, and various crop varieties can be tested within those fields, subplots. So the question is, an agricultural researcher wants to test two irrigation methods, drip irrigation and sprinklers, and three crop types, wheat, corn, and rice. Since changing irrigation methods, the individual plots is costly, irrigation methods will be applied to large sections, while crop types will vary within those sections. How should the researcher set up the experiment? So basically what's going to happen, we're going to answer that question by writing a program in Python. And so in order to write the program in Python, the first thing that we need to do is we need to import Python libraries. So we're going to import NumPy as NP, which is a numeric library that creates NumPy arrays. We're going to import Pandas as PD, which is a data processing library, which also creates data frames and series. We're going to import matplotlib.pyplot as PLT, which is a visualization library. So from scipy.stats, we're going to import f1way. So scipy is Python's scientific library, and stats is a statistical module within scipy, and f1way is the ANOVA task that we're going to perform. So the next thing that we want to do is we want to simulate data for the split plot design. The first thing that we do in that regard is we're going to set our seed. And so the reason why you set your seed is so every time you run the program, the variables will be set up to the same values. So you set your seed by typing np.random.seed and any number you want within the brackets. So what we're going to do now is we're going to define our variables. So irrigation methods is a list with drip irrigation and sprinklers. Crop types is a list with wheat, corn, and rice. So the irrigation methods is the main plot factor, and crop types is the subplot factor. And then what we're going to do is we're going to simulate crop yields for each combination. So data is a blank list or a blank array because there's no distinction between a list or array in Python. So for irrigation and irrigation methods is your first for loop, and then your second for loop is for crop and crop types. And then we're going to base yield and variability. If irrigation is equal to drip irrigation, base yield equals 50, else base yield equals 45. So drip irrigation gives you 50 and sprinklers gives you 45. So now we're going to add crop specific effects. So crop effect equals, and it's going to be a dictionary with wheat is 10, corn is 15, rice is 5, and that's your crop. And then now what we're going to do is we're going to add variability. So yields equals np.random.normal brackets base yield plus crop effect, 5, 10. And then so basically what that means is you're going to create a normal distribution, and the base yield plus the crop effect is going to be your mean, and 5 is going to be your standard deviation, and 10 is going to be the number of samples. And then it's going to collect the data for yield value in yields, data.append, brackets, irrigation, crop, yield value. Now what we're going to do is, after we have created our double for loop, we're going to create a data frame using pandas. So df equals pd.dataframe brackets data, comma, columns equals irrigation method, comma, crop type, comma, yield. So that means comma in position 0, column in position 0 is irrigation method, and column in position 1 is crop type, and column in position 2 is yield. And then so now what we do is we summarize the statistics. So summary equals df.groupby brackets irrigation method, comma, crop type, square bracket, yield dot mean dot unstack. And then what we're going to do is we're going to print the statistics. So it's going to be mean crop yields, quintiles per hectare. So we come over here to the bottom of the cell, and you got your crop type is corn, rice, and wheat, and irrigation method is drip irrigation and sprinklers, and it gives you the values for all these variables for the columns and the rows. And then so now what we do is we go back to the code, and we're going to perform an ANOVA, and that's an analysis of variance. So your ANOVA is going to be a blank, ANOVA results is going to be a blank dictionary. So for irrigation and irrigation methods, crop yields equals square brackets DF, square brackets DF, irrigation method is equal to irrigation, and DF crop type is equal to crop, square brackets, yield for crop in crop types. So that's like a Pythonic for loop. And fstat, comma, p-value equals f1 way, and it's brackets, asterisk, crop yields. And ANOVA results irrigation equals f statistic and the p-value. So we're going to print the ANOVA results. So we're going to print ANOVA results for each irrigation method. For irrigation, comma, results in ANOVA results.items, print irrigation is f statistic equals results f statistic, comma, p-value. So what we're going to do is we're going to go back down to the bottom of the cell, and then we get our ANOVA results for each irrigation method. For drip irrigation, the F statistic is 13.937. Your p-value is 0. So with the p-value is 0, it is less than 0.05. So that means you have to reject the null hypothesis and accept the alternate hypothesis. And the alternate hypothesis is significant differences among crop types. And with sprinklers, the F statistic is 7.163 and the p-value is 0.003. Okay, so that's still less than 0.05. So that means you reject the null hypothesis and you accept the alternate hypothesis where there's significant differences among crop types. So you're going to have significant differences among the crop types. So now we go back to the code, and it says if results of p-value is less than 0.05, print significant differences among crop types. And that's exactly what it did. And then so now what we're going to do is we're going to visualize the data using Matplotlib. So plt.figure brackets fig size equals 6,4, summary.plot brackets kind equals bar, comma, fig size equals 6,4, comma, alpha equals 0.8, comma, color math equals Viridis. And now we're going to customize the plot. The title is Crop Yields by Irrigation Method and Crop Type. Y label is Mean Yield quintiles per hectare. And then the X label is Irrigation Method. X ticks is Rotation equals 0. The legend is Title Crop Type. And the grid is axis equals Y, comma, line equals dash, comma, alpha equals 0.7. And then we show the plot layout type. And so this is the plot that we have. Crop yields by irrigation method and crop type. So you've got two irrigation methods being drip irrigation and sprinklers. And then you have three crop types being corn, rice, and wheat. And then you have mean yield of quintals per hectare. So you can see that the yield is greater with drip irrigation than it is sprinklers. And you can see that on the chart that's been created. So it would be up to the farmers to decide whether they wanted to use drip irrigation or sprinklers. And obviously they'd have to perform a cost-benefit analysis on that too to see if they could afford it. So that concludes this video. The next video is going to be another exponential design video. And so I hope that you decide to watch it.